Okay. So now, problem 1, determine if the following functions are power functions. If yes, identify the coefficient k and the exponent p. If not, say so. So this first one here, we have a, y equals 0.8x to the power 4 over 0.2 x. Now, our goal here is try to manipulate this and simplify this so that it looks like this up here. Okay. Anyone know, can anyone give me the first step that we could do to simplify this?
Would you divide the 0.8 and 0.2 first?
Good, sure. And what do you get when you do that?
You get 0.4 or 0.4.
Don't you just get 4?
Oh, yeah, my bad.
That's okay. Okay, so then you'd have 4x to the power 4 all over x. Is there anything else we could do to simplify this?
Could you minus the powers from the x's, so it's like 4x to the third?
Yes, good. We have 4x to the power 3. Now, do we have a power function?
Yes.
What's my constant?
4.
And what's my power?
3.
Good. Any questions on that? Okay. Moving on to B then. We have y equals the square root of 9x to the power 8 over x. Okay. Can someone, well, tell me if you can simplify it, and if you can, give me the first step or a first step that we could take.
Would the 9 go to 3?
Yeah, we could take the cube root or the square root of 9 and we get 3. What do I do with the square root of x to the power 8?
Would you make it x to the 8 over 2?
Good. X to the power 8 over 2. And then we could just keep the bottom as x. Now this 8 over 2, we could simplify to 4. So we could rewrite this as 3x to the power 4 over x. And then now what's my last step in simplifying?
Subtract the exponents.
Good, so we have 3x to the power 3. Is this a power function? If so, what's my k and p?
3 and 3.
Good. K equals 3, p equals 3. Any questions here?
How did you get to the 8 over 2?
Good. I'm very happy you asked that question because I'm sure many others have that question. Okay. Remember, so how we got from here to here. I'll do it in green down here. We have the square root of 9x to the power 8. If I just isolate that one part, I could rewrite as parenthesis 9x to the power 8, close parenthesis, raised to the power of 1/2. Remember, when we have any sort of root, a square root, cube root, whatever, we could write it as an exponent as 1 over the root number. Okay. Then from here, you could go ahead and multiply the 1/2 and the 8, and you get 9x to the power 8 over 2. Sorry, hold on. I did that not efficiently. Now, the 1/2 is raised to everything. So you have 9 to the power 1/2 times x to the power of 8 over 2. The square root of 9 is 3. X to the power 8 over 2, we could write as x to the power 8 divided by 2 is 4. Does that make more sense?
Yes, thank you.
You're welcome. Okay, next, if we look at C, we have f of x equals 1/3 times 3x plus 1. From here, can we simplify this?
Yes.
How would you go about that?
I think I'd multiply 1/3 to 3.
Okay, so you can and you can't do that, right? We could rewrite this as 3x plus 1 to the power of x plus 1 over 3. We could simplify it that way, and that's more simple, and that works. But is this 3 here also raised to the power of x plus 1?
No.
No. So can we combine this at all anymore?
No.
No. Good. And actually, I guess you could subtract the exponents, but you'd still end up with an addition in the exponent. So if we go ahead and subtract the exponents, we have 3 to the power of x plus 1 minus 1. And then if you go ahead and continue,
So
we
you
have,
apply the 3 and the 1/3?
so you could subtract it because it's the same base. So if we keep going, we have x plus 1 minus 1, so 3 to the power x. Is this a power function?
No.
No. Good. And you could see that from the beginning, from the first step here, because the x is in the exponent. But if you didn't notice that right away, you could go through these steps of simplifying and end up with not a power function. Any questions on that one? Okay, problem D. We have g of x is equal to 0.01 x to the power 6. How can I go about simplifying this? Hold on, actually, before anyone answers that. When you do 3 divided by 3, why isn't it 1? Good question. We don't end up with 1 as our base here. When we divide this, we don't end up with 1 as our base because we have different exponents, right? Just like over here, when we had x to the power 4 divided by x to the power 4 divided by x does not divide to 1. So 3 to the power of x plus 1 divided by 3 to the power of 1 does not divide to 1. Does that make more sense? You're welcome. Okay, so now back to letter D, we have g of x equals square root of 0.1 or 0.01 x to the power 6. How can we simplify this? If so, how?
Take the square root of 0.01, which is 0.1.
Good. But we can't just take the square root of this.
And then you'd make it x to the 6 over 2.
Perfect. Okay, before we move on with the next step, did that step confuse anyone? It's the same thing that I did over here. So this to this is the same thing that I did over here. It's the same reasoning. Okay, now from here, how can we go ahead and simplify this?
Make the exponent 3.
So, good, so we have 0.1 x to the power 3. Do we have a power function?
Yes.
And what's our k and p?
K is 0.1 and P is 3.
Good. Any questions on that one?
Wait, is the square root of 0.01 0.1?
Yes.
Okay, I just make sure.
Yep. Okay. Next we have E. We have h of x is equal to 0.01 x to the power 3 minus 2x squared. Can we simplify this?
Do you like combine the term? Oh wait, no, you can't. Can you?
Good catch, good catch. Okay, we can't simplify this. I'm glad you said that, Faith, because a lot of people would want to combine it, but you can't because we have different exponents. So this is not a power function.
So if it was the same exponents, then you would be able to do it?
Correct. Yep.
Okay.
Is it like, not that this happened yet, but like if it were to be negative, can the or whatever the k is can be negative?
Yep. The coefficient can be negative. We'll get to what that means when we move on, or when we do other problems, when we look at graphs. But it can certainly be negative. Yep. And same with the exponent, actually. We'll get to that. Not this section. Next section will be negative integral exponents. And then lastly, we have problem F, which is y equals 9 times the square root of x to the power 5 over 5. Okay, how can we simplify this?
Isn't it over x?
Yes, yep. Thank you. I wrote 5 again. X, okay. How can we simplify this?
Would you rewrite what's under the square root like as x to the 5th minus 1?
So we'd have this equals 9 times the square root x to the 5 minus 1 is x to the power 4. And now what can I do from here?
Make x to the square root of x to the 4th x squared.
Good. Anyone, did I lose anyone in the step from here to here?
Wait, why would they go to x squared?
So it's going to x squared because the middle step here is that you do 9 times x to the power 4 over 2. Right, our square root tells
Oh,
us
yeah, all right, I got
to
it.
raise to the power of 1/2. Yep. Any other questions? Is this a power function?
Yes.
Okay, and what is our k coefficient in exponent?
The coefficient is 9 and the exponent is 2.
Good, great. Any questions on this page? Okay, moving on to the next page then. Okay, so problem 2. The braking distance of a car is proportional to the square of the car's speed and depends on the coefficient of the friction, mu. This is the Greek letter, it's called mu. Mu, Greek letter. It depends on the coefficient of friction, mu, between the tires and the road surface. Let D denote the distance in feet and S speed in miles per hour. The formula for braking distance is D equals 0.034 over mu at times S to the power 2. Okay. Is the braking distance a power function of speed? If so, give the coefficient K and the exponent P. Assume that mu is a given constant. Is this a power function?
Yes.
Good, yes it is. Can someone else tell me what my coefficient is?
Is it 0.034 over mu?
Good, over mu, yep. Because for this problem, it says that we're assuming mu is a given constant. So depending on the road's conditions, we'd be given mu and this is our coefficient. So what is my exponent?
2.
2, good. Good. All right, any questions on that one? Okay, moving on to question B then. The coefficient of friction under normal conditions when the road is dry is mu equals 0.7. What is the braking distance of the car that travels on a dry road at 35 miles an hour? What is the braking distance at 70 miles per hour? So let's start with one sentence at a time. That one's pretty loaded. The coefficient of friction under normal conditions when the road is dry is mu equals 0.7. So let's figure out what function we're working with first. So we have d sub dry equals 0.034 over 0.7. I got that value from here times s squared. The next question says, what is the braking distance of a car that travels on a dry road at 35 miles an hour? Can someone give me insight on how to go about solving that?
You would plug the speed in for S.
Good, we'll plug 35 in for s. So we have the distance on dry land or dry roads at 35 miles an hour is 0.034 over 0.7 times 35 squared. Someone do that in their calculator for me?
I got 59.5 feet.
59.5 feet. Can someone else confirm that, please?
I got the same.
Okay, cool. All right. Now we have to do the same thing with 70 miles an hour. So we have the distance on dry roads at 70 miles an hour is equal to 0.034 over 0.7 times 70 squared. Someone, two people at least, do that in your calculator and let me know what you get.
I got 116.62 feet.
Did someone else get anything different maybe?
I got 238.
That sounds more right.
Yeah, I got 238 too.
Okay. I couldn't tell whose green light answered with the first answer. Maybe you just entered it in your calculator wrong. Remember, in your calculator to put parentheses around your fraction and then make sure that you're only squaring 70. That could have been the issue. And you said you guys got 238 feet. Great. So question C, by what factor does the braking distance increase when speed doubles? Okay, this one's a little tough unless you think about it quite a bit. So let's consider d dry of 35. Let's just write out what that was again. That was 0.034 over 0.7 times 35 squared. So it's just 35 times 35. Okay. Now we want to know what how much the braking distance increased when the speed doubled. So let's try it with 70, right? 70 is double 35. So let's do d dry of 70 is equal to 0.034 over 7 times 70 times 70. But I just said that 35 is 2, or 2 times 35 is 70. So let's just rewrite it. So we have 0.034 over 7 is the same as 2 times 35 times 2 times 35. Do you guys agree with me?
Yes.
Okay, now this here is all multiplication. So we can rewrite it yet again as 0.034 over, sorry, this should be 0.7 over 0.7 times 2 times 2 times 35 squared, which is also the same as 0.034 over 0.7 times 4 times 4 times 4 times 35 squared. Okay, so what factor did we increase by when the speed doubled?
4.
4, good. So when the speed doubled, the braking distance increased by a factor of 4. Any questions?
Is there any other way to find that answer?
There definitely is a rule on it, and let me just pull up your textbook to see the rule exactly. I would actually, yeah. I will.
I mean, I was just wondering because I don't know if I would have been able to figure that out on my own.
Yeah, you might not have thought to do that. Well, another thing that you could do is do 238 divided by 59.5, and what do you get?
4.
4. So you could also do it that way. But yeah, that's how I would go about doing it if you don't think to do it the other way. But I wanted to make sure you guys saw this way to see why that's the case, right? Like why, like it, now it does make sense that, or I hope it makes sense that it's increasing by a factor of 4.
Okay, thank you.
Okay, next is problem D. The coefficient of friction on a wet road is mu equals 0.4. Calculate the braking distance of a car traveling at 70 miles per hour on the wet road. So what is my distance on a wet road function look like?
0.034 divided by 0.7 times.
Careful. That's the.
Oh, 0.4.
Yep, 0.4. Good.
And then multiply that by 70 squared.
Good. 70 squared. Our input is 70, and someone do that in your calculator, or a few people, and let me know what you get.
I have 416.5. I don't know if that's right.
I got that as well.
Yeah, me too.
It makes sense with the word problem, so I Concur. All right, any questions on that? Okay, moving on then. Each of the following are graphs of the power function y equals k times x to the power of p, where p is a positive integer. In each graph, determine the exponent, if the exponent p is even or odd, then determine the coefficient k, if the coefficient k is positive or negative. So we talked about this in the beginning of class. We said that if p is even, we have some sort of parabola. If p is odd, we have something, a chair or an S or whatever you want to call it. I think most people call it a chair. But if k is positive, then the functions stay in the same direction. If k is negative, then they flip. So anything with an even power will look like that, and anything with an odd power will look like that. It's kind of a messy graph up in the corner, but just to kind of walk you through them. There's a really good, in your textbook, there's a really good, on page 110, there's a really good picture of what happens. It's a little 4x4 picture, and it shows you, you know, all possible combinations of even and odd and positive and negative coefficients and exponents, okay? So go ahead and check that out. Yes, I will go back to problem 2 when we're done. Okay, so with that being said, we have to determine if k is positive or negative and if the power is odd or even. So for A, is the power odd or even?
Even.
Good. Is the coefficient positive or negative?
Positive.
Positive. For problem B, is the coefficient positive or negative?
Positive.
Is the power even or odd?
Odd.
Okay, and then someone new for the last two, or one person doesn't have to answer the last two, but I want new people talking for the last, for C and D. Is the coefficient even or odd for C?
Odd.
Odd, good. And is the power positive or sorry, hold on. I said the wrong thing. Is the coefficient positive or negative?
It's negative.
Negative.
Negative, good. Now, is the power even or odd?
Odd.
Odd.
Good. And for D, coefficient positive or negative?
Negative.
And power even or odd?
Even.
Even.
Even, good. Any questions on any of those? Problem 4, which of the following is the graph of the function?
I have a question for B and C.
Yep,
So they're both. Oh wait, never mind.
okay. Okay, knowing how it's even or odd, we'll go over that one more time. Actually. Okay, if I have a graph, and we know f of x equals k x to the power of p. If p is even, the function's going to look something like this. It'll be some sort of U. It could open, close, you know, whatever, but it's some sort of U. So that's P is even. If P is odd, sorry. Yeah, P is odd, oops. Odd, we have this chair shape function where it goes down like this, through the center and back down, through the origin and into the third quadrant. Okay, so that's if P is even and P is odd. Now, on top of P changing, K could change. K, if K is positive, then these two cases are what you have. Then you have either this one or this one. If K is negative, then if K is negative and P is even, you end up with an upside down U. Think like a parabola. If K is negative and P is odd, you have the opposite, like this. The opposite, the flip of the chair function. Does that make more sense?
Yeah.
Yeah, okay. One thing that you could notice is that you only go into this quadrant. Your function only goes in this quadrant if K is negative. You'll notice that, like I said, like a parabola, when P is even, it's going to face up if K is even and down. I mean, if K is positive and down, and K is negative, just like we did with quadratics. And the rest of it, I would, again, page 110 in your book has a really good image to help you study if you're visual. Okay, so now for part B, problem B, problem 4. Which of the following is the graph of the function f of x equals negative 4x to the power 5? So what do we know about this function? What is my k value?
Negative.
Good. We have negative k. And what do we know about my exponent?
It's odd.
Is odd. Good. Okay. So let's start with P is odd. Are any of these not for P is odd?
C.
C. Good. So we could X-nay that. Okay. Now we have K is negative. So we have two functions with odd exponents happening here. One where K is positive and one where K is negative, right? There's only two options and they're opposites. So which one is K is negative?
B.
B. So that's our answer here. B is our answer. Any questions there? Okay. Lastly, problem 5. Below is the graph of the following. Y equals negative x to the power 4, y equals 1/4 x to the power 4, and y equals x to the power 4. Decide which is which. Okay. They all are raised to the power 4, so they're all even, which is why they're all U's and hills, and so that makes sense. But what's changing? Our k value is changing. We have a negative k, we have a fraction k, and we have k equals 1. The easiest one to start with is probably the one that is the only different one in terms of positive or negative. So which one is y equals negative x to the power 4?
C.
Good. C is y equals negative x to the power 4. Okay. Next we have 1/4 x to the power 4, or x to the power 4. Now, you could explain this. There is a saying that fractions make it fatter, right? If you have a fraction in a function, in a power function, and everything else is happening, it's going to make it fatter. Okay, but I want you to understand why, because we're going to be dealing with a lot of different fractions and stuff, and come time for the final exam, you're going to be like, wait, fractions where make what fat? Like, it's not going to make any sense. So I want you to understand why. We have y equals 1/4 x to the power 4 and y equals x to the power 4. All we're doing is these are functions, and it's for every x value along this x-axis, a y value is plugged in. This one here, or actually this one here, y equals x to the power 4, is some value, say 2 raised to the power 4, which is 16. Okay. This function here, y equals 1/4 x to the power 4, is taking this y value and dividing it by 4. And when you take a y value, so if your y value is initially here, and you divide it by 4, you're making it shorter, right? So that means that it's going to take longer for you to get to higher values. Does that make sense?
Yes.
Yeah? I could explain it again because it's a lot of kind of just following along, which I know can be tricky in general, but especially on Zoom. So when you have a fraction, it's going to make your function wider because it's making the output, the y value, smaller. So your function is going to stay close to the y-axis longer than a non-fraction function. So which one is y equals 1/4 x to the power 4?
A.
A, good. And then obviously the last one is b, y equals x to the power 4, because that's all that's left. Okay, any questions for me? Gee, sorry. If you guys have no questions, you are free to go. Have a great weekend. Don't forget to submit this by midnight. It should be done now, so submit it right now so it's done.